YouTube right now? Are you live on TikTok?
No. Aaron was giving me so much crap for my clicking on my on my mouse. Click, 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 click.
Oh.
Okay. We are live.
Let's see. I'm not seeing. Oh, there we go. There we go. I see we are live on YouTube.
Is there sound?
Unclear. We will get comments soon. But I see it bouncing.
Well, that's good. That's a good sign. I think that's more than we had last week, huh?
Yeah, and then on yours, the sound is just coming through there. So will it be synced up with your picture? Unclear.
Right.
Did you go live on TikTok?
Mm-hmm.
Great.
We are live for MaTHURSDAY. All right, everyone, welcome to MaTHURSDAY. Where we have a little AMA. I'm a math teacher. I've been a math teacher for 20 years. Ask me anything. If you have any problems, any questions, any tests coming up, or anything like that, this is your chance. Let me know. Let me know what we should go over. There is a little viral, oh my God, where did my phone go? A little viral, yet another order of operations, little viral problem, I guess. Let's see, okay. Another poorly written problem, but let's get into it. So as we know, right, order of operations is such a big thing, and it's very controversial. But it shouldn't be controversial because it just is what it is, right? That the order of operations is just, that's how we do it. So this one, this little PEMDAS thing, 6 divided by 2, parentheses 2 plus 1. Okay. So this is the latest in poorly written order of operations problems. Okay. So what do we think? So we've got this, we've got 6 divided by 2, and then we have in the parentheses 2 plus 1. So the first thing we're gonna do is we are going to take care of those parentheses. Now, one thing that always throws people off is when we take care of what's in the parentheses, and then, nice, we're getting some good guesses in the chat. We're gonna take care of the parentheses, right? So we're gonna add 2 plus 1. Now, when we take care of the parentheses, once we do this operation, something that throws a lot of people off is you can drop the parentheses once you have taken care of what's in there, okay? So I've got 2 plus 1, which is 3. So I can drop the parentheses now. Everything else stays the same. So I've got 6 divided by 2 times 3. So I can change this to a times because 2, like any number right next to the parentheses is a multiplication. It's another way of writing writing multiplication. So now we just go left to right, right? So we go 6 divided by 2. Hold on. The reason we go left to right is because you go multiplication or division left to right. That's the piece that people always forget, is you want to go left to right with multiplication or division, whichever one is left to right. So 6 divided by 2 times 3, so 6 divided by 2 is 3. 3 times 3 is 9. Yeah, that's what it is. So what you can also do is, again, it's a poorly written problem. It just is. because it causes so much confusion, right? So we're gonna do, so again, yes, it's please excuse my dear Aunt Sally, but the my dear and Aunt Sally, they can be any order as long as they're just left to right. Okay, so the multiplication and division, because they are the same operation, right? 6 divided by 2 is the same thing as, so let me get another board. So 6 divided by 2, 6 divided by 2 is the same thing as 6 over 2. Okay. The division symbol is actually a fraction bar. Did you guys know that? That those little dots there represent like, oh, that dot is a 6, that dot is the 2. Okay, so the division symbol does mean a fraction bar. So 6 divided by 2 is the same thing as 6 over 2, which is the same thing as, move it up, 6 times 1/2, which is the same thing as 3. Okay, so when I'm looking at this, a lot of people get hung up on like, oh, you've got to distribute that 2. No, we do not have to distribute the 2. Okay, the reason we aren't going to distribute the 2 is because this 2 isn't actually right there. It's actually connected to that 6. Okay, so this is not 6 divided by 2. It's like 6 over 2, like 6 divided by 2, like really fast. Okay, so it's 6 over 2. So what you're actually multiplying by is 3. So I could distribute a 3 because it's the same thing as 6 over 2, because right here, right, 6 divided by 2 is the same thing as 6 over 2 is the same thing as 6 times 1/2, which is the same thing as 3. So this 6 divided by 2, I can rewrite it. If I rewrite it as 6 over 2 times 2 plus 1. Okay, now that 6 over 2, oh, that's kind of hard to see. Well, hopefully you guys are okay. 6 over 2, which is actually becoming 3, all right? That 3, 2 plus 1, now I could distribute that, okay? So 3 times 2 is 6, 3 times 1 is 3, 6 plus 3, we get 9 again, okay? It's really mathed up. Okay, so we've got 6 plus 3 is 9. So these are all these different ways this equals 9. Now again, you guys know that I hate these problems because they're just poorly written. The reason that these things are going viral is because they cause so much strife, right? Because you could certainly justify that it would be 1, right? The only other option that I can really think of is that you might get 1, right? Which is if you did 3 and then 2 times 3 and then 6 divided by 6, which would give you 1, right? So proof that the order does affect the product. Right, so the thing is that the order does affect the product because it goes into the commutative property, which is talking about the order. Now, the commutative property is where you say that, so the commutative property is one that's pretty important, right? It's that like 2 plus 3 equals 3 plus 2, right? So the commutative property means that the order doesn't matter, but it really only applies if you're talking about addition and multiplication, okay? Now, I can make it so it still works with subtraction and division, but I have to keep in mind that subtraction is the same thing as adding a negative. So if I just had 2 minus 3, 2 minus 3 is not the same thing as 3 minus 2. But 2 plus negative 3 is the same thing as negative 3 plus 2. Okay, so if I keep it as addition, it works. Okay, So same thing with division, right? So 6 divided by 2 well, let's say this. 6 times 2 is the same thing as 2 times 6. Right? 12 equals 12. 6 divided by 2 is not the same thing as 2 divided by 6. But again, the commutative property applies if it's addition or multiplication. So if I change this into a multiplication problem, then I can make it commutative. And again, 6 over 2, right? 6 divided by 2 is the same thing as 6 times 1/2. And that is the same thing as 1/2 times 6. So the order, yes, the order makes a difference. No, it doesn't always make a difference. That's a really clunky way of saying that. But the commutative property applies, but only if you have addition and multiplication. So again, with this, if you think about this, now you've just got like 2 multiplication pieces, right? So we've got 6 over 2, which is 6 times 1/2. And then you've got times 2 plus 1, if we take care of that 3, right? So no matter how you slice it, you're gonna get 9 for this problem. It's just how it is. Okay. Oh my goodness, there are so many people in here tonight. So the most recent comment I saw was tips on helping 3rd graders with multiplying 9s. So there's a lot of interesting things. Oh, I love multiplication and division rules. So the nice thing about 9s is that you know if something's divisible by 9 if the digits add up to 9. So that really comes in handy when you're looking at, especially when you're like doing common denominators or when you're doing like simplifying fractions, right? And if you see that it's like this big number, but it's 18, let me write it down. It's 18 over 144, okay? I can look at this and I can go, oh, they're both divisible by 9 because 1 plus 8 is 9. 1 plus 4 plus 4 is 9. Great. So I'm going to divide both things by 9. Divided by 9. Divided by 9. So I get 2 over, let's see, 9. Okay, 144. Yes, I can do this in my head, but I want to kind of show you guys how it looks. So when I do this division in my head, here's what I see. So I see 9 goes into 14 once with 5 left over, and then I kind of push that 5 over in my head and I get 54, and then 9 goes into 54 6 times, okay? So then I've got 2 over 16, and then I go, oh, 2 and 16, those are both even numbers. I know they're divisible by 2. So now I'm going to divide them both by 2, and I get 1 over 8. Okay? So if you know that it's divisible by 9, then kind of picking up on like what the patterns are can really help kids like memorize the 9 times tables, right? But there's a lot of other little tricks you can do, and I think I've showed this one before, but I love it so much. So if you're looking at really like 1 through, I mean like the 9s, really if you're looking at 1 through 10, right? An easy way to look at it is if you have something like 9 times 3, right? So one thing you can do is hold out your hands and you go from the left to the right and you count 3 times. So you go 1, 2, 3. I'm gonna put that finger down, and what I'm left with is 20 down here and 7 here. So 9 times 3 is 27. Okay? Then, I don't know, 9 times 4, right? 1, 2, 3, 4. So now I have 30 and 6. Okay? You can also tell them like anything, you know, and really you're going to be looking at like, if you're talking about third grade, right? We're talking about third grade, like multiplication. Again, a way to check if they got it right is, do they add up to 9, right? That's a good place to start. And then also you can say, all right, well, if it's 9 times 5, right? So 9 times 5, 5 minus 1, is 4. What do I need to add to 4 to make 9? It's a 5. Well, it's 45. This is how I learned it. I actually didn't know the like hand trick until I was teaching. And then somebody showed me and I went, oh, it really surprised me that it did actually work that way. It's great. But this is how I kind of always did it. And I still do it this way too. Okay. I think, okay, 9 times 6 minus 5, that's 54, right? So if you have 9 times 8, right? 8 minus 1 is 7. What do I need to add to 7 to make 9? 2. So 9 times 8 is 72. Okay. Now somebody asked, oh, of course I erased it. The fraction that I had on earlier where we simplified down by 9 and then we simplified again by 2. Why couldn't you just have simplified it by 18? Sure, I could do that, but I don't really have the 18 times tables memorized. So I just do it by 9 and I do it by 2. So when you're simplifying fractions, you know, again, it's not necessarily the most efficient way to simplify these things. But that's okay. Like, it still gets there. It still gets done. Okay? All right, so I hope that helps for that. Let's see. Ooh, division. Okay, so I'm assuming that this is like long division. Long division. And I'm sorry, I'm not sure how to say GT? I'm sorry, I'm probably butchering that. Okay, so long division. Okay. I was just working on long division with a student today. Let's see. So it'll probably be, well, hopefully it'll be multi-digit, I'm sure. And you know, it's one of those things that you do forget. You do forget those things if you don't use them in a while. And, you know, we were all told growing up in like the 80s and 90s, we were all told like, well, you're not going to have a calculator in your pocket every day. And now look at that, we do. So we lose some of those skills, but it's okay because they're, it's kind of like riding a bike. You sort of remember and it all starts to come back to you, I promise. Okay, so let's do, I'm just gonna use my calculator to get, 2.2 divided by 500, or 500 divided by 2.2. 2.2 divided by 500. Ugh. Oh, wow. But let's start, actually, you know what? I'm gonna flip that. There we go, 500 divided by 2.2. That makes a little bit more sense. Okay, because actually somebody had asked also about, doing division of decimals. Okay, so that's another thing. So I'm glad that you suggested this problem. So 500 divided by 2.2. So when you say that 500 divided by 2.2, okay, when we've got that, like the whole like dividend, divisor, all of that kind of thing, I'm not going to use those terms because everybody this, you'll there I am.
Wait, hold on.
Oh,
Cool.
what?
The record's going.
Okay, we're good?
Yes.
Okay.
So go back and just say.
Okay, so 500 divided by 2.2. So again, when we have 500 divided by 2.2, you have the little house, right? So 500 goes inside the little house and 2.2 goes outside. Okay, so we've got 2.2 into 500. Okay. Out here, you don't want this to be a decimal. Okay, so what we do is we are going to move this decimal over so that it's a whole number. And then we are going to also move the decimal over for this one in here. Okay, because what we do to one, we got to do to the other. So I'm going to add in a 0 as a placeholder, but now what I'm looking at is 5,000 divided by 22. Okay, I'm going to rewrite those 2's because I don't like the look of those 2's. Okay, so 22. All right, so we're looking at 5,000 divided by 22 now. Okay, so when we're going through this, we're going to look at this digit, how many times it goes into these along here. So the first one we're going to look at is 22 into 5. Can't do that, right? Then I'm going to look at 50. Oh, 22 can go into 50, right? I know it can go in once. I know it can go in twice, which would be 44. Can't go in 3 times because that would be 66. So I'm going to go with 2. Okay, I'm going to change my marker because that green is kind of hard to see. Okay, so now I do 2 times 22, and that goes under here. And I subtract. Division is all about that repeated subtraction, just like multiplication is repeated addition, right? 3 times 5, you can go 3 plus 3 plus 3 plus 3 plus 3. Well, with division, you can go minus, 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 right? Like 15 divided by 3, you can go minus 3, minus 3, minus 3, minus 3, minus 3, and it takes you 5 times to get down to 0. So repeated subtraction now, okay? So 50 minus 44 is 6. I bring down the 0. So now I'm looking at 22 into 60. Okay, now looking back up here, 2 times 22 is 44. And again, 3 times 22 would be 66, so that's not gonna work. So we put another 2 up here. 2 times 22 is 44. We subtract again, and I get 16, right? 60 minus 44, so I can think of this in a couple different ways. I can do the 10 and borrow the 5. Can also think about like, well, 44 plus 6 is 50, plus 10 is 60, so I've got 16. Okay. And now I'm bringing down another 0. Okay, so now 160. Okay, so now what we're looking at is we're gonna look at, let's see, 22 into 160. So let's start thinking about, so 5 times 22, I'm gonna kind of move this over so we get a little more board space, right? So now I'm trying to figure out, okay, what can I multiply 22 by to get up as close to 160 as I can without going over, okay? So I'm gonna start with 22 times 5. 22 times 5, okay? I can do this a couple different ways. I'm just gonna go with the old standby of like the kind of basic algorithm. Okay, so that's 110, so I'm about 50 off. So why don't I try 22 times 7? So 7 times 2 is 14. Whoops. 7 times 2 is 14, plus 1 is 15. Oh, 154, that's it. We've done it. Ah! Oh no! I got marker on my white shirt. I lasted through the entire day of school with not spilling anything onto my white shirt. And now, oh, dang it. All right, well, I'll just have to throw it in the wash. Okay, where was I? 7. All right, so 7 times 22 is 154, just like we just calculated, right? So I've got 154. I'm going to subtract there, and I'm going to get 6, okay? Now, I've got this remainder, okay? But depending on how far they want you to go, like if they want you to go to the tenths or the hundredths or the thousandths, right? We can keep on going, okay? We've got the decimal here. It's good. Got the decimal because it's right above this one, right? So we want to make sure that the decimal's in the same spot, right? It's all lined up. So now I've got 6, and if I need to keep going, I'm going to bring in another 0. So now I'm at 60. No, I'm at 60 again. Hey, Hannah, congratulations on your big win. So we've got 60 up here, and that kind of looks exactly the same like this, but let's just stick with it. So when I had 60 here, I did times 2, all right? So then I've got 44, so I'm gonna subtract 44 here, and I'm with 16 again. Now I'm gonna start seeing, wait a second, this is just gonna keep on repeating, right? Over and over and over and over. So 160, that was the 7, right? And then it would just keep going and going and going, right? So depending on how, like what place value they want you to go to, depending on the place value that they want you to go to, you can like stop here. It's going to be 27, 27, 27, 27. It's just gonna keep repeating on and on and on, okay? But this is the key for like the long division algorithm, right? Just kind of like you multiply and then you subtract and then you multiply and then you subtract. You bring it down, multiply, all that. That whole pattern never changes, right? Okay, and once you start seeing it repeat and it just keeps repeating and repeating and repeating, this is gonna be kind of your end point, right? So this would be 227.27, 27, 27, 27. So if they ask you to round it to the tenths, it would be, this is the tenths place, so you would look next door. And if it's over 5, you would round up. If it's under 5, you stay where it is. Okay? All right. Good luck on your test. Okay, let's see. Calculating the area of a circle. Okay. Calculating the area of a circle. So, the area of a circle. Circles are really interesting. Circles are really neat because they show up an awful lot. They're kind of like fractions. They just never really go away. Those circles keep showing up again and again and again. I'm doing trig with my students now, and I'm just like, oh, great. Oh boy, we're back at circles. So the area of a circle. The area of a circle is pi r squared. Okay, this is just the formula. Okay, so area is how much is sort of like filling it in, right? I always think about it as like area would be like how much grass you need to lay over it or how much paint you need to cover it. And then circumference for a circle, it's sort of like the perimeter of a circle. Okay, so circumference is the distance around the circle. So like how much like fencing would you need, right? Or how long would it, would you be walking around there, right? So the circumference of the circle is pi times the diameter, okay? And we've got, there's the center of the circle. That would be your radius. The radius is the distance from the center to the side. And it's gonna be the same all the way around. That's the definition of a circle. So the definition of a circle is it's all the points that are the same distance from a center point. Okay, so a linear equation, right? A line is always just the infinite number of points that meet that relationship or that show that relationship. So if you've got a line, great, that's all the points, right? If you've got a parabola, that's all the points, x and y. If you've got a circle, it's all of the points that are that distance from the center, right? Think about a dog like on a like leash or on a lead, right? It's gonna be running all the way around, but it can't go any further than that leash will let it, right? So that's your radius, is the length of that leash, right? Your diameter is the distance from one end to the other. That line was very wobbly, sorry about that. From one side to the other through the center point, okay? So that's the diameter. Now the diameter is the same thing as 2 times the radius, okay? So sometimes, I don't know where my voice went on that one, but sometimes you'll see the circumference formula as 2 pi r. So sometimes you'll see it like that. I prefer doing it with pi times the diameter, and here's why. Is because I really enjoy like mnemonic devices, right? And little kind of tricks, right? Like commutative property, I always remember that by like, oh, it's your commute. Like whether you're driving to school or home from school, it's your commute. You're going the same distance, right? It doesn't matter if which order you're going in, okay? With this one, I like thinking of the word, this is so funny. The word area is a short word, or it's shorter than circumference, but it has the longer formula, and circumference is the longer word and has the shorter formula. I just have mnemonic devices for everything. So area, short word, big formula. Circumference, big word, short formula. So that's why I tend to use the pi times the diameter, is because that way, like, because 2 pi r and pi r squared, I think those can get really mixed up easily. So that's why I just usually stick with these. Okay. So finding the area is gonna be pi r squared. Now, a lot of times, teachers will say, especially when you're first learning about pi, and I wonder, nobody really talks about where pi comes from. Do you know where pi comes from? So pi is this really kind of magical number that mathematicians, like ancient mathematicians, started to notice that the relationship between the circumference and the diameter of the circle, of any circle that they could find, that the relationship between the circumference and the diameter was always around 3. So the circumference was always about 3 times the diameter. Didn't matter what size the circle was. It was always the same. So the circumference, the distance around, was always 3 times the diameter. So as calculations and stuff like that, as they did more like work onto it, then you've kind of figured out that like 3.1415, blah, 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 on and on and on and on and on. Okay. But isn't that a cool origin? Like, that's so fascinating to me that that's something that you just kind of start to notice, right? Like all of those relationships that you first start to notice, like this circumference and diameter, oh, it's about 3 apart. That's crazy to me. But anyway, area is pi r squared. So if you want to use 3.14 instead of pi, you can if you want to find like an approximate calculation. But if you are asking, if somebody's asking you to do a, if somebody's asking you to do like an exact answer, that means they want you to leave it in pi. Right? Because 3.14 is not going to give you the exact measurement that you need or want or whatever you're kind of looking for. Okay? All right. Oh, if you take the ACT, just use pi, please. Yeah, just leave it as pi. Be comfortable with seeing pi just as itself, right? Like, or as itself, just by itself or with a coefficient or anything like that. And when you get into trig, like somebody mentioned the unit circle, whew, it's everywhere. I'm deep in that with my students right now. There's different ways to measure the angles in a circle, like when you're talking about trig and talking about the unit circle. So you've got the degrees within the circle itself, and then you have like pieces of pi. The circumference is measured in like lengths of pi or units of pi, and those are called radians. Where can I find your online tutoring? Click on my profile, and you should be able to, you can book online tutoring, and we've got a whole thing set up where we've got like a questionnaire that you can fill out so I can get a good idea of what we need to work on. And you can, you can set up like PayPal and all of that kind of stuff. So yeah, check it out. Click the link and do the stuff. Okay, let me see. Have I missed any other questions? Okay, yeah, trig is all about that. Okay. All right.
Did you bring home your giant velvet bag?
I didn't bring home my giant velvet bag of dice. It's because I use them every single day. I'm afraid I'm going to leave them at home. I use them every day.
The random comments were long division using decibels.
Which we just did.
Okay, great. Factoring and binomials, college algebra. 9-year-old says major meltdowns, can't recover.
Oh.
Get them past that.
Makes me sad. What's your question about Pythagorean theorem in the chat? Put your Pythagorean theorem question in the chat, and I'll answer it. I love Pythagorean theorem. Speaking of ancient mathematicians, whew.
Did you do how to add decimals?
I can do adding and subtracting decimals.
Well, yeah, TikTok search just recommended there's not a lot of videos on that, so.
Oh, interesting. Yeah, we can do some decimal stuff.
And then advice for parents who feel lost, I guess. Helping their kids.
Advice for parents who feel lost helping their kids. Oh, man. Hashtag same. It's really difficult, that dynamic between like parent and child, especially when it comes to math. So something that I hear all the time about, like, from parents is like, well, I'm not good at math, so I don't even know how to help them. But you want to frame that conversation in a different way. You can say something like, I really struggled with math in high school. Let's learn this together, right? Let's figure this out together. Can we Google this? Because typically, you as a parent are going to be more kind of savvy of like where to look things up, right? There's a lot of different websites that are really helpful, right? There's a ton of YouTube videos out there. Watch the YouTube video together, learn together, right? And even, pull up some TikTok videos, learn it together. But I think a big part of the kind of the meltdowns and things like that is when you have like the kid, the student feels like, it starts beating themselves up because they feel like they're not getting it, and you're getting frustrated, and everybody's getting a little like, everybody's getting heated and excited, and just calming it down and just saying like, look, I don't really know how to do this either, but the but is the big part, right? I don't really know how to do this either, but let's figure it out together, right? Showing them that you're not really sure, but you have the confidence to actually try it, right? So don't be afraid to try things. Don't be afraid to be a little bit vulnerable with that, right? Don't say, I'm bad at math, because you're not. You can do math too. But you may just not have learned it yet. That's fine. Learn it now. Learn it with your kid, right? It might be really nice for you guys to learn it together, and then you can both make these discoveries together, and it becomes more of like a partnership as opposed to like everybody getting frustrated and tears. That's my advice. I am not the expert, but I've been doing this a while, so I've seen a lot. But
well, maybe talk about this week how, you know, like even personal struggles with your own child.
oh yeah, my own child was in tears when I was trying to help her with 6th grade math. So you are not alone. But it's that whole like dynamic between the parents, especially when your parent is a math teacher who like makes her living doing math and you don't get it. You're not understanding it. Like, it's a huge amount of pressure. And also it was just a really long day and I was cooking dinner and so, but instead she went over to my husband and they worked together to kind of figure out what the problem was. So just being a little bit vulnerable with that kind of thing and like just kind of being patient and learning it together, and you know, time helps everything. So, you know, it's challenging, but it can be done. Okay, I'm seeing a lot of quadratic functions. I'm not sure who this person is. Can you do quadratic functions? Can you give me an example of a quadratic function question that you're asking or that you're being asked? Okay, so I've got another order of operations, 12 divided by 6 times 5 plus 1. Oh, pancake mix is back. Can you please show how to factor because I am so confused for algebra 2. So pancake mix, are we talking about factoring trinomials like x squared plus 3x minus 10, something like that? Okay, so factoring trinomials, and then that may lead us into quadratic functions. Okay, give me the example. Let's see. Lengths of sides of sides A, B, and BC. Oh, that was the Pythagorean theorem. Okay, wait, hold on, sorry, I gotta... Okay, 1 and 1 comma, lengths of sides A, B, and BC. I'm not sure. Okay. All right, negative 4x squared plus 22x plus 21, plus 12. Okay. Is this the actual problem? Because sometimes you give me the wrong problem that's written out. And you mess me up, pancake mix. The magic X. Oh, you can do the magic X. Okay, so negative 4x squared plus 22x plus 12. So you can do the magic X. I have a really hard time doing the magic X too. I have a really difficult time visualizing that. So like for my students, if they do it that way and that makes sense for them and they get it, like totally go for it. But personally, I have a difficult time with that. So I'll just walk you through how I would do this and if I had this on a test or something like that. But yeah. So negative 4x squared plus 22x plus 12. So here's what I would do first is I can see the first thing you always want to check for when you're factoring. Let me turn this. So the first thing you always want to check for when you're factoring is a greatest common factor. Okay. So a greatest common factor in this is something that they are all divisible by, right? So in this case, I've got 12, 22, and 4. Now, yes, so you can take out a 2, but I'm actually going to take out a negative 2. Okay, and that's because that negative right there, I don't want it. Okay, so I've got negative 2, and I'm going to leave that out here. So I've got negative 2, and then I have to think about, okay, what is left over when I divide everything by negative 2? So this is going to be 2x squared minus 11x minus 6. Okay. So now I have this, so I've got 2x squared minus 11x minus 6. Okay. When I am factoring a trinomial like this, now this -2 that's out here, that's just gonna hang out for a while. Like, I'm done with that, but I still need to include it in everything, but I'm mainly gonna focus on this 2x squared minus 11x minus 6. Okay, so I'm actually gonna switch colors just because I'm just gonna focus on this. So when you're doing this, since this first coefficient is 2, it's not 1, what I'm going to be looking for is I'm going to do 2 times -6. That's going to give me -12. Okay. So I'm going to be looking for factors of -12 that factors that multiply to -12 and add to -11. Okay. So when we think about the factors of 12, like you first off the bat, you think 2 and 6, you think 3 and 4. The one you might forget about is 1 and 12, and that's the one we're gonna use. Because if this number is negative, right, that means that my signs need to be opposite, okay? Because they would multiply together to make this a negative number. So that means that one needs to be positive, one needs to be negative. And they need to add to -11. So I can't make -11 from 2 and 6. I can't make it from 3 and 4, but I can definitely make it from 1 and 12, and it is, you are absolutely right, 1 and -12. Those are going to be my two factors, okay? Now this part gets a little bit weird, but it's just kind of the same thing. So what I'm gonna do is I'm going to split this -11x into my 1 and -12. And the order doesn't actually matter. It'll all work out in the end, okay? But I'm gonna do -12x here. So I'm gonna split this middle term into -12x. Sorry, I didn't want to write that negative that high. -12x plus 1x, which is still the same thing as -11x, right? I'm just substituting. And the reason I'm substituting this in is because I want to be able to then factor it again by grouping, okay? So then I'm going to bring down the -6, and I'm going to bring down the 2x squared, okay? And then we don't forget about the -2, right? Don't forget about the -2. That's going to come down too. Okay, but I'm just gonna focus on this, okay? So now I can do something called factoring by grouping. Okay, so we're gonna factor this by grouping. And doing that, since I have 4 terms, I can factor this by grouping. So here, I'm gonna look at this. I've got 2x squared minus 12x. I'm gonna pull the greatest common factor out of there, which is 2x. So I've got 2x, and what's left over is x minus 6. Okay. Now here, with plus x minus 6, there's no GCF there. But what I can always take out is number 1. So I'm gonna rewrite this as 1 times x minus 6. Okay. And again, yes, I still have the -2 out there, right? We're still gonna keep it going. Okay. So now when I have this, so they don't cross out, but I can now factor those out, right? Because this is being multiplied by the same thing and this is being multiplied by the same thing. So you want to make sure that these two match. If they don't match, you've done something wrong. Maybe you missed a greatest common factor or something like that, right? So if they don't match up, double check. Maybe there's a negative, maybe you forgot to take out a 2, something like that, okay? But now, so I'm gonna shift this up so I have room, okay? So now I'm going to rewrite this. I'm gonna write my -2 out here, okay? And then this 2x plus 1 becomes my first binomial. Okay. Oh, sorry, that should be all over. Okay. And then my second binomial is x minus 6. Okay. And that, if I multiply all this together, it would actually work exactly backwards. It would just go right back up and we would end up back here. So this is what you would get. Okay. Now, if that first term doesn't have, I'll get to solving that one in just a second. Okay, Tama, sure. If this first one doesn't have a coefficient, or if it's just a 1, you don't have to do all of this. Once you figure out these, that's just what your two binomials would be. It would be like x plus 1 times x minus 12, right? But that's just if you have that first coefficient of something that's greater than 1, right? Then you have to do that 2 times negative 6. So if you're looking for more examples of this, this is usually, I think it's called like the AC method. I was thinking of AC Slater. Okay, but I think usually like the AC method is how I go about it, right? Yeah, because it's the A times the C, and then you go from there and then factoring by grouping. Okay. All right, so solving quadratics.
Did you see the givens?
What?
The given terms on the quadratics.
The gibbons?
The
What?
one person that gave you givens.
Oh, givens. Given is 3, 2, and 2, 1.
And then it's a quadratic function.
So is it saying a given quadratic between those 2 points? I'm not sure what that is. But okay. So, but let's do a little bit of solving the quadratic functions, okay? So if I have something like, well, let's just, you know what? I'm just going to use this. I'm going to use this as a jumping off point. Okay, so let's say I've got 2x squared minus 11x equals 6. Okay. So something like this. Okay, there's a few different ways to solve quadratic functions. There's, you can solve by factoring if it's factorable. You can solve using the quadratic function, which works for any quadratic function. Sorry, the quadratic, I don't remember if I said this. Sometimes I say things and I don't realize what I said. You can use the quadratic equation. You can use the factoring. If you're solving by factoring, you're going to be using the zero product property, which I would wager a guess that everybody knows what it is, even if you don't know what it is, right? Or you can do completing the square. That's one option also. So when we're doing this, I'm going to do this because I know this is factorable because we just factored it. But the first thing you want to do is you're going to set it equal to 0, which means I'm going to subtract 6 from both sides. So I've got 2x squared minus 11x minus 6 equals 0. Okay, so again, I know this one is factorable, okay? And the reason I know this one is factorable is because we just did it, but also because you can do 2 times negative 6 is negative 12, right? And what we realized was that the two factors that I can use are negative 12 and 1. So I'm going to split this middle term into minus 12x plus 1x minus 6, 2x squared up here equals 0. Okay. When I do that, then I'm going to factor by grouping, right? So this one here, my GCF for 2x squared minus 12x is 2x. And what's left over is x minus 6. Okay, now here, again, there's no greatest common factor, so I just factor out a plus 1. That's all I can really take out of there. And then I'm left with x minus 6. And again, this equals 0. Okay. Then I factor again, right? And I get 2x plus 1 times x minus 6 equals 0. Okay? So here is where you can solve this. Okay? The zero product property, the ZPP, the zip. Okay? We've got so we've got two things that are being multiplied together and they equal 0. What has to be true? One of them has to be 0, right? In order for this to happen, one of these has to equal 0. That's the only way that you can get it, right? The only way to multiply two things together to get 0 is if one of them is 0. So now I've got two possible outcomes. Either, let me use my cleaner board. I've got two options. I'm going to split this up. So it's either true that 2x plus 1 equals 0, or maybe x minus 6 is the one that'll give us 0. All right. So if 2x plus 1 equals 0, then the whole thing equals 0. And if x minus 6 equals 0, the whole thing equals 0. So now I'm solving. I'm going to subtract 1 from each side. I get 2x equals negative 1. I'm going to divide by 2. I get x equals negative 1/2. Okay? Or add 6. I get x equals 6. So my two possible solutions here. I use a little curly brace. Oh, I gotta move this up a little bit. Sorry. I'm gonna use my little curly brace because I'm listing these values. They're not, well, I'm not listing them as coordinates right now. I'll say it that way. So I'm gonna have negative 1/2 and 6. Those are my two solutions. Okay. Now the way this looks on a graph, right, the reason why this is the way that it is because 2x squared minus 11x minus 6, that quadratic, it's a parabola. Okay, so it's gonna look, yeah, it's gonna open up. It's like this. Okay, it's a big U shape. Okay, and what it's gonna look like, let's see, negative 1/2 and 6. So it's gonna look something like, not that. This negative 1/2 and 6, that is negative 1/2 and 1, 2, 3, 4, 5, 6. That means that these are the 2 points that curve goes through. So it's gonna look something like that. Okay, it might go down further, I'm not sure. But that's what it's gonna look like. So that is where the solutions actually come from, is that you're trying to figure out what values for x will give me 0 for y. Those are what the solutions to those quadratics actually mean. So that's why, like in the quadratic function, it's plus or minus the square root, right? You're either gonna add it or subtract it, the square root of that number, because there's different options, okay? So this is one way of solving those, and this is, again, solving by factoring. It doesn't work on every single quadratic, okay? It works on, it doesn't work on every single quadratic because it's only gonna work if it's factorable, right? And not every single quadratic is going to be factorable, okay? factor the polynomial 12h squared minus 5h minus 25. Okay. Let me see. Oh, and that's all we got right now. Okay. Okay, so 12h squared minus 5h minus 25. And this might be all we really have time for. Let's see. We'll do 12h squared minus 5h minus 25. Do we know that this one is factorable? Let's see. Okay. So here we've got our, it doesn't matter that the variable is h. The variable can be whatever it is, okay? If we were trying to actually solve this, right, you would probably just see this as x just because of like the graph piece. But sometimes they put in different variables. It still all follows the same pattern and all that. Okay, so we're gonna do, we've got the AC method, right? We've got 12 times negative 25, which is negative 300, I believe, but I'm gonna double check. 12 times negative 25, negative 300, okay. So we're looking for factors that multiply to negative 300, which means one's gonna be positive, one's gonna be negative, right? Because it's negative, one will be positive, one will be negative. Now here's my clue. 300 has a ton of factors, okay? But my clue, to kind of narrow my scope down a little bit, I know for sure that this is not 1 and 300 because this is negative 5. They're gonna add to negative 5. So what that means is that they're gonna be pretty close to each other. So I'm wondering if maybe it's, I think it's maybe 20 and 15. It is 20 and 15. Woohoo! I'm pretty good at this, guys. So 20 and 15. Okay. But again, if you don't have that like right at your disposal, like you don't see that right away, you can just kind of plug and chug and just kind of check all of these different numbers, right? Now the question is 20 the negative or is 15 the negative? So to figure out that, we have to look at that middle piece right there, right? So that negative 5 means the bigger number is the negative, right? Because negative 20 plus 15 is negative 5. 20 plus negative 15 can be positive 5, and that's not gonna work, right? Okay, so now what do? We split the middle. So we're gonna split this into negative 20h plus 15h. All right, I gotta erase my little factors because I'm gonna run out of room. These are big numbers, my goodness. Minus 25. I've got 12h squared here. Okay. Oh, I didn't mention at the very beginning, but you do want to always double check to see if there's a greatest common factor here. But there isn't. Like I had done that check, but I just didn't mention it. So 12, 5, and 25, there's no common factor for all of those. So you don't need to worry about that. So now I'm going to go into my grouping. Okay, so I'm looking at 12h squared and 20h. So GCF, let's see, we've got 2, not 6, 4. 4 is a common factor, so we would take out the 4, and since they both have one h in them, it would be 4h. And what's left behind is 3h minus 5. Okay. Now what we're looking for is we do want this to be the same thing that's left over here. Because if it's not, then we can't continue factoring it because we've probably made a mistake somewhere. That's okay. We just go back and check our work. Not a big deal. So 15h minus 25, so definitely 5, right? So we can do plus 5, and what's left over is 3h minus 5. Okay. So since these are the same, then I can take that one out and I can leave this behind. So my solution is going to be, these are my two binomials, 4h plus 5 times 3h minus 5. And there you go. Okay. And you can always go back and double check it, right? 4h times 3h is 12h squared. 4h times minus 5 is negative 20h. Plus 15h is negative 5h. And then plus 5 times negative 5 is negative 25. This is more, you're welcome. This is more into Algebra 2. Sometimes you'll see this in Algebra 1. But this is more of an Algebra 2 concept, because then you go into solving these quadratics. So this is much more into like the Algebra 2 realm of things. So, yeah. And your college algebra class. Yeah, so college algebra, well, it depends on if it, so college algebra, yeah, that's usually kind of a blend of Algebra 1 and Algebra 2. But yeah, so that's sort of, it's just kind of all algebra, right? I prefer in Europe and England when they say maths. It's just all maths, because it's all, there's lots of different maths that you can do. All right. I think we're about good. So if you got, I'm here every Thursday, 8 o'clock. It's usually about an hour or so. If you want to book me for like online, like one-on-one tutoring or anything like that, click the link and do the stuff. There's a sign-up link and a sign-up page, or you can shoot us, you can send us an email, send us a DM or anything like that. Have a wonderful evening. Keep mathing and keep it fun. Bye.
Cool. Done on YouTube.